transparent object, which will permit a body or material that permits transparent material or object, a body which permits light to pass through it. What are the best example? Glass, plastic, water. So what they will do, they will permit the light to pass through it. So these are some various things what happen. We are able to this one. Okay, now okay, these are some terms which will be which are going to help us a lot. Okay, these terms. Let me highlight. Okay, now I think when we get into the when we start the next topic, no. So these terms I'll be using very often. So you should not get troubled with these terms. These are very generalized terms which will be using very often, in the entire discussion. Now, one more thing, like for the light to to see particular the phenomena or the particular thing to experience, or when the light should interact with the matter. Means like a light ray, if it doesn't interact with matter, what happen? The light ray will continue to move. Only when it like if it interacts with matter, the light ray what happen? If it doesn't interact with matter, the light ray will continue to move. This is one property of light. So we'll never get a light which will be at rest. So usually when you say light ray, what is the state of light ray? Light ray will be in propagation, will be in motion. In vacuum, it will propagate with a speed 3 into 10 to the power of 8 meter second. So what is the conclusion we can put? A light ray travels forever unless it interacts with matter. There's the last one, very important condition. Light ray continues to travel forever unless it interacts with matter. This is one very primary condition. So we'll never see light ray at rest. Light ray will be propagating. And there's a basic condition. Okay, now what are the next thing? Properties of light. Properties of light are reflection, refraction, dispersion, interference, polarization, interference, polarization, diffraction, photoelectric effect. So basically, what is the light? Light, shall we call it like a electromagnetic wave? Yes, those things open we'll get into as we get into the next chapters. So they will call it as like a light as electromagnetic wave. Later we are going to put that the light is an EM wave in that polarization chapter. So the light what happen is having a dual nature, one particle nature and the dual nature. So photoelectric effect supports particle nature of it. All these will support wave nature of light. So what is the rectilinear propagation of light is rectilinear propagation of light. What Newton proposed, like the light what happen will propagate in a straight line, and it will deviate only when the medium in which it is traveling through changes density, that one. So when it moves from one bit and the middle open, it will change its direction. Otherwise, what happen? It's going to continue. It's like a straight line path here. So we'll call it as light travels in a straight line, and light only deviates from a straight line when the medium in which it is traveling through changes. Okay, there's one, the very fundamental rectilinear propagation of light here. So if the homogeneous medium, the light will continue. So light, so what is the one more conclusion we can? Light continues to move in a straight line in homogeneous medium, which has same refractive index throughout. So as long as what happen, the refractive index of the medium remains it's same at all points, the light will continue to move in a straight line. This is one property of the light. So why the light moves in a straight line? This is one property of light. This also will come under category of property of light. Okay, so this is about the initial introduction part before entering ray optics. So I just wanted to put back one very important term. What is that? What is a ray optics, or what do you mean by geometrical optics? The light energy propagates. The direction of propagation of the light energy we show by one straight line or by one ray. We'll assume that the beam of light, its thickness becomes very so small that I can just draw a one line. And what is a ray optics? It's a geometrical representation of direction of flow of light energy, which will really help us to learn the optics in a very simplified and systematic way. It's an approach. So don't think that the light will have a ray. No, the light energy will propagate. The direction of propagation of light, what happened? We represent by a straight, by an arrow, by a ray. What this one? So what is that? Shall we say that ray optics is nothing but like a geometrical representation of the direction of propagation of light energy? That's what here. So here of dots happen. The light energy means I'll show by the rays. A light is coming from a source. So I'll just draw a light. So what is the conclusion now? If there's a source, I'll switch on. Then the light will be coming radially outward. There's a much easier way, no, geometrical way of showing the direction of flow of light energy. What do these straight lines with arrows indicate? They'll indicate the direction of flow of energy. So this is what the geometrical optics means. This is what I wanted to conclude here. Okay, no. So in the next class, we'll deal with these properties. We'll take one by one, each one property. We'll bring some laws which will define this property of light. Then we'll go for application numericals, all the theory and application numericals related to the front. So what is all our entire ray optics? We'll be dealing with these things, ray optics. The wave optics will deal with these things. The photoelectric effect will deal the particle nature of light. Ray optics is not about particle nature of light. Ray optics is about the rectilinear propagation of light. Got it? No? So the ray optics is what we will study using this. This will be much easier. Using wave nature of light, we'll study these three properties. Particle nature, I'll study this property of light.